G'day all building improvement students. So I'm recording this video to go through the bracing requirements for Project 1 at Shepherd's Hill Road. So I'll include these slides on the Learn page, or possibly by the time you see this, they'll be up there already. So for doing our structural bracing on the building, we do that in accordance with AS 1684, so it's a document which you should be fairly familiar with by now in terms of carrying out timber framing. So the relevant sections in there, obviously section 8, racking and shear forces bracing, so general temporary bracing and wall and subfloor bracing. So we're not concerned with temporary bracing, but we are concerned with 8.3 wall and subfloor bracing. And then taking a snip here of the section 8.3, so in general, bracing should be designed and provided for each story of the house and for the subfloor where required in accordance with the following procedure. Determine the wind classification. So on our property, we don't have to do that because we've already got that N2 wind classification from SA Map Viewer. For more rural properties, you will have to do that wind speed classification. Determine the wind pressure. So we're looking at how much, we're looking at the square meterage of the building the wind is acting upon, and then how many kilonewtons of force that wind provides on the building in accordance with the wind speed. So we'll go through that just very quickly. So that's from determine that area of elevation and multiply that by the wind pressure to get our racking force being applied to the building. And then design a bracing system for the subfloors or walls. What we're not going through today is bracing for subfloors, but we are going through bracing for walls. Some other points, check even distribution and spacing, and check connection of bracing to roof, ceiling and floors. So bracing does get a little bit tricky in terms of there are certainly many little aspects that are unique to each type of bracing. I won't be going through it, pouring through it in that sort of detail. I do suggest you sit down with this for a decent amount of time at some point in time. Maybe get a copy of AS 1684 and read it from front to back. But spend some time on the bracing and look at each of the clauses carefully. But I'll be giving you a bit of an overview of it and then how it can be applied to our project. So for our house, or for any house really, what we're doing is we get half the height of the floor to underside of the eaves, and then the whole of the roof area in elevation, and that's the area that we use for calculating the amount of force on the building. So within a computer-aided drawing program, that's fairly easy to grab that area. You can do that very quickly to work out that surface area, and then you multiply that by the figures given in the tables. Now, when you've got a gable end or the end of a skillion building, that means where the wind is pressing against a flat surface, you have to use table 8.1, and for N2 we're looking at 0.92 kPa per square metre. So we multiply our kPa by that square metre and we'll get our kilonewtons there. So let's say we're 10 square metres of effective area, we're 9.2 kilonewtons of force being applied to that side of the building. And when we've got a hip end or a sloping face of a double gable ended building, we refer to table 8.2. So I don't have I've only just taken the top snip of that table, but for, let's say we were N1 and we have 6 metres width of our building with a 15-degree roof pitch, we're only at 0.39 kPa. So 0.39 multiplied by, let's say we're 20 square metres this time, we would be 7.8 kilonewtons acting on the building. So once we know our total kilonewtons acting upon the building, then we go about designing our bracing. And then within AS 1684, there are a whole series of different types of bracing. So if I bring up AS 1684 here, and I'll just scroll quickly down to our bracing section, up a little bit, where I select 22. So here we have our different types of bracing. Scroll through that slightly quicker, get up to our strap bracing. So our strap bracing, the simplest form of that is type A, one single diagonal strap, and type B, a double diagonal strap. The reason that we use bracing in a diagonal fashion is because as the wind applies a racking force to a rectilineal object, it will want to elongate that object from corner to corner. So if we have bracing going from corner to corner like this, it will resist a force coming in this direction. If we have a force coming from right to left of the page, then we want our bracing in that direction there. So when we have double strap bracing like that, that will resist forces coming from either direction. But it's not, well, actually before I go on to that, so we've got our type A and our type B. Now they will provide 0.8 kilonewtons per linear metre and then 1.5 kilonewtons per linear metre of bracing. But do beware that there are limitations. So we have an angle here between 60 and 30 degrees, which for your standard height walls available within AS 1684, which is a maximum of 3 metres high, we have to keep our bracing length to above 1800 and less than 2700. So there's only that 900mm range within which we can have our bracing. So we can't do really short walls with it, and we can't do, or if we want to do long walls, well then we have to break it up into several sections. There are actually short wall bracing designs that are not included within AS 1684 that can still be used. So they're proprietary systems. If you were to go to a company like Pryda, P-R-Y-D-A, and search for short wall bracing, you'll see their short wall bracing details for that. But with that diagonal strap, if we want to increase our bracing capacity, say 3 kilonewtons per linear metre, then we apply tie downs over the top. So that's the difference between type B and type D bracing. Is there are little tie downs here near the termination of that bracing, and so top plate and bottom plate, to increase the bracing capacity of that section. Also, another form of bracing which is really common is hardboard bracing. I just went past our ply bracing. That you see a bit of plywood bracing as well, but quite often you've got your hardboard bracing here. I'll screw it up. Our hardboard bracing type A will provide 3.4 kilonewtons of bracing per linear metre. So that's not a diagonal strap. That's a piece of hardboard nailed off to the building. One and you have to get those nail spacings correct for that bracing to apply. Another form of bracing which is really common is we're seeing a lot more now is OSB sheets, so oriented strand board bracing. For that, if you use it with this type B with 12mm, M10 tie downs, you can get 6 kilonewtons per linear metre of bracing capacity. So if we refer back to our types A, little a, then that was 1.5 kilonewtons, and then our type B here, capital B, we can achieve 6 kilonewtons per linear metre. You can increase that, like as in type C, but you have to have an M12 rod in there. So you can get a fair bit more bracing capacity by employing the sheet bracing and using masonry anchors in the bottom plate to secure that bottom plate. Right. So we've got our different types of bracing, and so we've calculated how many kilonewtons of force are acting on the building, and then we resist that force by imposing bracing. We have to impose that bracing on the floor plan in a uniform fashion and at maximum spacings that are dictated by AS 1684. So typically you've got maximum spacings of 6 metres throughout the building, and then also your bracing is most effective on the corners. So you start by placing your bracing on the corners. That is just a very brief snapshot of bracing. So there are more complexities to it, but for our project, we're already given the bracing. So somebody has already determined that bracing for the building, and we are just to impose that onto a plan. So if you complete task 3, so the quiz in task 3, you get access to this bracing information. So having a look here, we've got type A with a capital A. When we refer to type A as a capital A, we're not referring to our strap bracing, we're actually talking about our type A hardboard. So when we see a capital A, we're talking about hardboard, but then we've got type B, little b, so that's referring to double strap brace with no tie down at the ends of the brace. So this is so we've got some hardboard brace, we've got some type B brace, hardboard, type B, hardboard, type B, hardboard, and then a type D. So type D and type B, they're both with a 30 by 0.8 galvanised iron strap. The difference is type D has the tie downs at the end. So that's been designed to resist these kilonewtons of force. One important thing to note is that it's talking about the western corner of bed 1, northern wall of bed 1. So this is our floor plan here for the property. That assumes that north is facing towards the left of the page. So north, south, east and west. That means our western corner of the wall, so type A 900 for western corner bedroom 1 is this little corner here. Northern corner, or type B, northern wall, western 1. Oops, sorry. So north. Oh, sorry. That. So I might be. So type A, northern corner for bedroom 2, bedroom 1. Sorry. North on our building is facing up on the page that way. So our type D is on the northern side, and we've got southern and western for our type E sheet bracing. So when you look at the building is to be oriented in that fashion with, the building to be oriented in this fashion with north facing up on the plan. So once we work out which of that bracing is going where on the building, then we show that bracing by our type B is a double strap, so we use an X for that, and then our type A we use a solid flat line for our type A, and then our type D is like the type B, except we enclose those two ends with the two strap. That indicates that those tie down bits at the end of the bracing. Another thing is that you need to put in the details of how that bracing is to be fixed on the page. A very good way of doing that is to go straight to AS 1684 and get this information. So cut this from AS 1684 and impose it directly onto your plans to show that how that bracing is to be carried out. That saves you having to retype all of this information and reproduce all of that information, which can be included from AS 1684. So that's very much how we go about doing our bracing plan. So we want to show that on there. The only thing I I would add of note, and I'll scoot in just a little bit more, is just on a couple of these walls, the bracing has been indicated as sitting on the inside face of the wall. I'd sit all the bracing on the outside face of our wall. The reason for that is because we don't want builders thinking that bracing will go on the inside face, because otherwise it's going to get in the way of our plasterboard. And one other small note in regards to this is, typically when you're doing a frame and cladding building, you're not going to impose sheet bracing in one section and then strap bracing in another, because that sheet bracing means that your weatherboards will stick out an extra 6mm here, and then that has to be absorbed somewhere along this line, probably meaning that the carpenters on site are going to have to do cut lots of rips of 6mm bracing to be nailed to all the studs along this side here. I prefer to use hardboard bracing here and then just carry that all the way through. So use hardboard bracing there as well instead of that type B, because things like your OS brace sheet are really quite cheap, and it's going to be cheaper pretty much to pack out that whole wall using whole sheets than to sit there cutting rips for much of the day. So that's only a small consideration. If you produce your bracing plan much like this, or modify it to produce something quite sensible, both options are certainly acceptable. So if you have any questions about that, please let me know. And that pretty much concludes what we need to look at, except for one other thing I just noticed. You should always show your kilonewtons of force acting on your building as well. So we show east-west, so a certain kilonewtons east-west and a certain kilonewton north-south on your plan. That's a good way in which to show that. So thank you very much.